Hello, dear students. Your science teacher Ben here, and I hope you are all doing great. And I'm sure you have gone through all the 3 chapters from chemistry portion that we have completed. Today we'll be starting physics portion. So we'll kickstart with the first part of the physics, that is chapter 10, light. Okay. So what is light? Light. Without light, you will not be able to see me, or you will not be able to see things around you. So how do you actually see and how do you visualize? See, when a light ray falls on an object, the object reflects the light, clear? And when this reflected light rays is received by your eyes, that's how you see, clear? So in this chapter, we will be studying reflection. That's given in your text, reflection and refraction. So we'll be studying these 2, reflection and refraction, details, but what is reflection of light and what is refraction of light? In a simple word, reflection means bouncing. You're familiar with the word bouncing. So it is bouncing back of light, reflection is, and refraction means bending of light, okay? Bending of light. Okay, so regarding light, the definition of light will be, it is a source of energy, okay, that enables us to see an object. So light is a form of energy that enable us to see an object. So object means anything around you, anything that is visible by your eyes. Now, do you know the speed of light? The speed of light in a vacuum or in air is 3.8 10 to the power 8. This is 8, okay? Make it clear. 8 10 to the power 8 meter per second in vacuum or in air, okay? So this, you remember, the speed of light in a vacuum or in air is 3.8 into 10 to the power 8 meter per second, clear? Okay, so this is about light. Now, first we'll study reflection, okay? We'll study reflection, and after that we'll study refraction of light. So in this chapter, we are going to study about images. We're going to study about different type of mirrors. We're going to study about lens. So this is a very interesting chapter, and the concept is very important because the same chapter you will, for those people who will be taking up science, you'll study this chapter in detail in class 12 in physics. Clear? So pay attention. We'll start with reflection of light. Clear? So reflection of light, as I have said, it is a bouncing of light. So example, take a tennis ball. If you throw the tennis ball, it will bounce back, right? So let's say this. Let's take this one as a mirror, okay? This is a mirror, and we have a shining surface here. So this is a plane mirror, and plane mirror, it's a smooth surface, you all know, right? So it's a smooth surface. It's a plane mirror here. Now, a ray of light will fall on this mirror. Clear? A ray of light. So a ray, this is the incident ray. So this, an incident ray, I'll write here, incident ray. Incident ray. So a ray of light falls on the plane surface here and the mirror. So it will bounce, and this point is known as point of incidence, okay? Point of incidence. Now, so the reflected ray will go in this manner. So this is the direction, and this is the reflected ray. Clear? And we have a normal here. A normal ray here is drawn here. It's perpendicular 90 degree here. So this is the normal. Now, from here, you are very clear about the incident ray and then the reflected ray. So when this reflected ray is received by our eyes, that's how the objects are visible to us. Clear? Now, we have two laws of reflection, which is very important. And if you understand this concept, the laws of reflection should be easier for you, because the law of reflection says that angle of incident is equal to angle of reflection. And the second law says that the incident ray, the normal at the point of incidence, and also the refracted ray, they all lie in the same plane. Clear? So I'll write the laws of reflection, but the second law, which I said that they all lie in the same plane, means we're not talking about this point, okay? But we are talking about the plane, this plane. Clear? So I'll write the law here. The first law would be, okay, wrap this. So this law is very important, okay? So laws of reflection. The first law, that is angle of incidence is equal to angle of reflection. Clear? Angle of incidence is equal to angle of reflection. Now, the second law, clear? The second law says that the incident ray, the normal at the point of incidence, clear? The one in the middle. The normal at the point of incidence, and the reflected ray. All lie in the same plane. Okay, they all lie in the same plane, not at the point of coincidence. Okay, okay. So note these two laws of reflection. Now we'll study about the types of reflection. Okay, types of reflection. If you are clear with this one, so reflection also we have two types. We have a regular reflection and also we have an irregular reflection. Clear? Regular reflection means, let's take example, the plane mirror, which are smooth. Clear? They reflect all the light. But now let's say, okay, this board, some of you might say that it's a plane, but it's not a plane. This type of board will be a rough surface. Clear? So there will be an irregular reflection. And how it is, I will show you here. Now, for a smooth surface, as I have shown below, like it was for the smooth surface, from the law we have studied that the angle of I this is the angle of I, okay? And this is the angle of R, reflected ray. For a smooth surface, angle of I and angle of R is equal, right? But now for a rough surface, what you'll get to see is, let's say rough surface, let's take this board, okay? This board, though it looks like plane to us, but it will be like this somehow. Clear? Or let's say paper. Paper will also not be a smooth surface, it will be a rough surface. So now, let's say the incident ray, the light rays are falling in this manner, but it won't be a parallel. Clear? Some will be like this, some would be like this, the reflected ray would be. So you see, now in this case, everything would be parallel. See, so there are two cases here, the plane surface and a rough surface. Now, so this is an example of a regular reflection, and this is an example of irregular irregular reflection. Clear? So I'm sure you're clear with the laws of reflection and the types of reflection. So if you are clear with this one, next we'll study images and mirrors. Okay, mirrors is very important for this chapter. After mirrors, we'll study about the lens. So now let's talk about images. Images, how many types of images are there, students? We have two types of images. Real images and virtual images. Clear? So these images, I'll just explain. I'll explain verbally, and I'll give you the example for real images and virtual images. But next, when we study about the ray diagrams, you'll get the details of everything, how to get a real images, how to get a virtual images. Clear? So real images are those like which we get from concave mirror gives us a real images. Clear? Convex mirror, they give us a only virtual images. And the plane mirror which you have at home, it gives us like a virtual images. Clear? So real images is where the reflected rays meet, they actually meet, the intersection happens. Clear? But for virtual images, the reflected rays, they appear to be coming from a point. Clear? One is they meet actually, one is they don't meet, but they appear to be coming from a point. Now, some of you might get confused, but when we start the ray diagram, you'll know what's the meaning of what about the meaning of the meeting and appear to meet. Okay, there's a very different word. Meet, appear to meet. Clear? Okay. So regarding mirrors, there are two types of mirror, plane mirror and spherical mirror. Clear? Plane mirror and spherical mirror. And plane mirror, I'm sure you all know. Two types of mirror we have. The first one is plane mirror, and the second type is spherical mirror. Spherical mirror. Plane mirror. Plane mirror is what you have at home. Clear? It's what we use at home. So plane mirror, you all know it's plane. It's not curved. It's very straight and it's very plain. Clear? So the reflecting surface, okay, I'll write the definition here for plane mirror. Plane. Clear? And what type of image do we get from the plane mirror? We get virtual erase from the plane mirror. And now in the plane mirror, the distance, okay, the distance between the image that you see in the mirror of yourself, clear? The distance between the image and the mirror is equal to the distance between the object and the mirror, clear? So the distance between the image, okay? When I say image, means the one that you get to see at the mirror, clear? The distance between the image and the mirror is equal to the distance between the object and the mirror. All the distance will be same. Is equal to the distance between the object and the mirror. Now the third point, the size will also be same, okay? The size of the object will be equal to the size of the image. So in the plane mirror, the size will be exactly same. The object, that is me or you, and the image, the size would be the same. Clear? Now, Okay, let's keep it simple. I'll give you last point here. The last point would be in a plane mirror, it is laterally inverted. Laterally inverted. See, the image that you get from the plane mirror is virtual and erect, okay? But it is also laterally inverted. The example is, see, have you observed this one? The left seems to be right and the right seems to be left in a mirror. Clear? So the left seems to be right or right seems to be left. Clear? So these are some properties of the plane mirror. And now we'll study the spherical mirror. Spherical mirror, you have to note down everything because this is the major part of this chapter where we'll study about the concave mirror and the convex mirror. Clear? So note down this one regarding the plane mirror. Okay. Students, the second type of mirror that we'll study, it will be a spherical mirror. Clear? And the spherical mirror, we'll see two types of mirror that will be concave and convex mirror. Clear? Concave mirror and convex mirror. Clear? Convex mirror. Now I'm sure you know the difference between concave mirror and convex mirror. Now let's take, okay, I'll give you a definition. We're going to study everything in details. But let's just take an example. Concave mirror, let's take a shining spoon that you have at home, okay? I'll give you the practical one, which you are familiar with. The shining spoon, let's say if this is the spoon, okay? If this is the spoon, that means the curve, which is inward, okay? The inward curve, like this one, inward curve is considered to be a concave mirror. See, the inward curve. Clear? That means we'll just assume that the source of light will be from this direction. Clear? Now, the outward curve, see, like this. That means if you take the shining spoon and this side, if you observe from this side, it will be convex mirror. So see, this is the difference. This is the concave mirror, which is curved inward, and this is the convex mirror. Clear? And I've given an example of a shining spoon, and from the shining spoon also there is an activity in your textbook. You can just look, you can just observe. Clear? So if you take this side, if you just take this side and if you just observe, if you bring it very close, you'll see very funny face of yourself. Clear? It'll be like magnified, enlarged. But again, if you take like far away, then it means you'll observe an inverted image. Clear? So, and again, for same, like for convex mirror, you have to observe from this side. You will see everything a wider field of view. Okay, so let's start with this concave mirror. Now you have to imagine that a hollow sphere, okay, or a hollow sphere, and then we are concerned about this one, and just imagine that this is an imaginary sphere, okay? And see, this part is what we are going to study. So you will not draw all the sphere, but you have to imagine that it is like from the sphere, it's coming from the sphere. So the center point is known as center of curvature. Okay? Center of curvature. This point, C, is known as center of curvature. And it will be the same for the convex mirror as well. Clear? See, you have to imagine that this is like from a circle. So this is from a circle, and then the center point here would be C. Okay? So I'll just rub this one. You have to imagine, okay? Because we'll not be drawing all the sphere. You have to imagine. It's an imaginary sphere. Clear? Okay. So this C is a center of curvature, and it is marked. It is marked by C. Clear? So the C in case of concave mirror would be in the front, right? See, The C would be here, but C, the center of that is center of curvature in case of convex mirror would be behind the mirror, here, behind the mirror. And for those people who are listening, you have to visualize it, okay? The center of curvature from the imaginary sphere. In case of concave mirror, the C will be in the front. If you're getting confused, I've given an example of the spoon. Clear? So the curved inwards, that will be the concave mirror. Now, so this, I'm sure you are clear with the C, center of curvature. So if you're asked definition for center of curvature of concave mirror, then you have to say that center of curvature of concave mirror, it lies in the front of a concave mirror. And for a convex mirror, it will be behind the mirror. Clear? Now, the next one is P, okay? P like in papaya, okay? That is pole, pole of a spherical mirror. You can write for pole of a concave mirror or pole of a convex mirror. Now, this pole is marked by P, clear? P, where will you find in the mirror? So, P, it is the midpoint of the reflecting surface of the spherical mirror. Clear? So this is the midpoint of the concave mirror here, and this is the midpoint. So P is the midpoint, the middle point of the reflecting surface of a spherical mirror. Spherical mirror, you can take example here. So see, this part convex, this part concave. So this is the P for convex, and this is the P for concave mirror. So this P is the pole of the mirror, okay? Now, the next one would be radius. Radius of curvature. Radius of curvature. It is marked by simply R, the letter R. So R, the radius of curvature would be the radius of the imaginary sphere. In the beginning, I said that you have to imagine a sphere. So the radius. So from this P till C, okay, P till C would be your R. If in case of concave mirror, from here, this would be R. This is R means radius, okay, R means radius of curvature. So this would be the radius for the curvature for the concave mirror, and that would be for convex mirror. Now, the next one, these are very important. This you have to remember. Without this, we cannot draw a ray diagram. Without this, we cannot define a concave mirror. Without all this representation, we cannot draw, we will not get an answer. Clear? Because in light chapter, you can expect 5 marks question. 5 marks question, you'll get numerical, and also you'll get a ray diagram. So all these are important. So same like for 5 marks, or maybe for objective, you should be clear with the concept. Clear? Okay, now this is, okay, next would be the focus, okay? Focus, principal focus. I'll write over here, principal focus. And it is marked by F, okay? F. So where you will get this F? F, it is a point. F is a point in a principal axis. So this line you'll see F. And how we will get F, I'll show you now here, F. Clear? So now let's say a ray of light. A ray of light is parallel to the ray of light. A ray of light is coming, okay, from this side, and it is parallel with this line, that is principal axis. Principal axis means the line joining the pole and the center of curvature. Clear? Principal axis is just the line joining the pole and the center of curvature. I'll repeat it. Principal axis is just a line joining the pole and the center of curvature. So now, if you see a ray of light parallel, okay, that means this is parallel, right? Parallel to the principal axis. Now, this ray of light, after hitting the mirror, it will pass through the focus. Clear? It will pass through the focus. So this principal focus is here, over here. Now, what about the focus for a convex mirror? Now, okay, now if a ray of light parallel to the principal axis, this is a ray of light, and this is parallel with the principal axis. Now, what will happen in case of convex mirror? Because the structure is different. And in the beginning, I've said that in convex mirror, you'll get an image that appears to be coming from a certain point. So this one, now it will bounce back here, but this ray, let's say this is F, this is C. This ray, it will looks like it is coming from this F, okay? So this is the principal focus. This is the principal focus, F is the principal focus. Now, even for the principal focus for a concave mirror, it will be in the front, and for a convex mirror, it is going to be behind. Clear? Okay, next is the focal length. Focal length. Focal length. Focal length is the distance between the pole and the F. Okay, the pole and the F. The pole and the F. Focal length is the distance between the pole and the F. And you'll also get a 1 mark numerical to find this focal length. Now the formula, how to get a focal length? It is the radius okay, to find a focal length, the formula is F is equal to radius, which I've already shown you before. You have to imagine that sphere, okay? From P till C, that's the radius of an imaginary sphere. So it will be just R by 2. Clear? So this is the formula for the focal length. Now, while copying down, while noting down, you also have to refer. You also have to refer the textbook. Clear? Okay. So we are clear with all the representation. Now I'll give you definition for a concave mirror, and where do we use this concave mirror, and where do we use this convex mirror, because these are very important. Clear? Now for concave mirror, the definition would be if the reflecting surface, if the reflecting surface of the spherical mirror, okay, spherical mirror is curved, it is curved, right? It is not a plane mirror. So it is curved outward or inward for concave. Students, inward, right? Inward, cave, inward. Curve inwards. Then it is known as a concave mirror. And it is also known as convergent mirror, okay? I'll just write in bracket. It's not known as convergent mirror. Okay, so note this definition. These definitions are important. And what about the convex mirror? If the reflecting surface of the spherical mirror is curved outward, right? So if the reflecting surface of the spherical mirror is curved outward, then it is known as convex mirror, and it is also known as divergent mirror. Divergent mirror. Clear? Okay. So students, note this definition down. I'll give you the uses. So where do we use this concave mirror? Have you ever seen, have you ever gone for a tooth checkup? Dentists, they use a mirror, right, to get a large image of a teeth. So that is used by a dentist. Clear? So if you are asked an MCQ and all, dentists use a mirror and they'll give you plane, spherical, concave, then you have to mention that it's a concave mirror. In that way, a question can be asked. Now, shaving mirror, clear? Have you seen a shaving mirror? A shaving mirror, if you see that shaving mirror, it will be curved inward to get the large image. Clear? So the example would be, another example would be shaving mirror. Let's say for solar furnace also, a large concave mirror is used. Solar furnace. Another very important use is solar furnace. Okay, now I'll write on top here, continuation. Okay, these are the uses. The first one I said, for dentists use this mirror, concave mirror. The second one, shaving mirror. The third one, solar furnace. Now the fourth one would be the headlight. In the headlight of a car, any vehicle, you'll see a mirror. And don't get confused. See, we have a rear view mirror, we have a headlight mirror. So don't get confused. The rear view mirror, you see a virtual image, right? Drivers and all they see. So you'll see a erect image, but it'll be a diminish. You'll get a wider field of view. But we are talking about a magnified image, which will only give us by concave mirror. Clear? So you have to keep this in mind. Magnified and erect means it is always concave mirror. So this headlight, why do we use this concave mirror in a headlight of a vehicle? Because it gives us a large beam of light. Clear? It gives us a large beam of light. Beam of light means it's a large number of ray of lights. Clear? Ray of light means just a single light incident, but a large number of ray of light means a beam of light. So you keep this in, you note this one down. It's used by the concave mirror. So see, I'll just give you the use of concave mirror today, not to confuse you. And we'll continue with the convex mirror, the uses of convex mirror in the next class. So note this one down. Just four uses. I'll give you another one, torch. Even in torchlight, so that I'm giving you many examples so that uses so that you can you can check now. Okay, you can just refer to that. And now the sixth one is also in a searchlight, used by the detective in our searchlight. So not all these uses, I've given around 6 uses. So not all these uses down: dentist, shaving mirror, solar furnace, headlight of a vehicle, torch, torchlight, searchlight, and all. Okay, note this one down, and we'll continue with another interesting topic, that is convex mirror, the uses. And next class we'll start with the ray diagram as well. So do continue with your regular studies at home. Okay, thank you, students. See you next class.